through the creation or the derivation of a formula for a trapezoid. Okay, and it's kind of an ugly formula, but you guys are going to be okay with it. You have seen all the components for this, but I like showing this. I think it's important to see this because though it's an ugly formula, the creation of it is pretty insightful on how our area formulas are related to one another. Okay, so we got trapezoid, just got one set of parallel sides. Okay. Do you guys remember taking the midpoints of those sides and get H and I, and then once I connected those, that segment right there, we called that a mid segment. Do you remember doing that? Does anybody remember the formula for that mid segment? If maybe I call that B1 and I call this one down here B2. Okay, good. So it's going to be 1/2 B1 plus B2. Okay, that is the length of H to I, and that's important for our development here in a moment of our area form. Okay, we need to start with that. Okay. Now, would you guys agree that if I put in those two dotted lines, that those are both altitudes? We start at a vertex, and I don't have the angles showing up, but they do go to the opposite side, and they're perpendicular to the opposite side, right? Okay, so at A, I've got right angles. Okay, so I've got a right angle right here, and a right angle there, and a right angle there, right? Okay, so those are altitudes. Do you guys agree that if I start moving those altitudes around, I don't know if I can, the way I've got it set up, that they're still going to be the same length? For instance, if I move them to right there, are they the same length? Are they the same altitudes? Does that make sense, everybody? So we can translate our altitudes. We can move them around, and they're still the same. So I'm going to do that. Okay. Would you guys agree then that when I do that, this is a right triangle down here? All right. Is this a right triangle down here? Okay. Now you can't really see it until I do that. Okay. But maybe I need to add a little bit something to this. Can I kind of extend those segments and get triangles up here that aren't colored in? Now I want to talk about the relationship between these two triangles. We know that H was a midpoint between A and B, right? So that distance and that distance are the same. Okay? This was a right angle here because an altitude had to be perpendicular to the base, right? For the same reason, this is a right angle because an altitude, by definition, is a segment that starts at one base and perpendicular to a line containing the opposite base, or the opposite side. So if I extend this opposite base, the opposite has to be perpendicular there. So that's a right angle. What do you know about that angle compared to that angle? They're vertical, so they're congruent, right? You have an angle congruent to an angle. Right, let me phrase that. An angle, both the right angles, and then these acute angles. So you got angle, angle, and then a non-included side, right? So those two triangles are congruent by angle, angle, side. Is that right? If they're congruent by angle, angle, side, what do you know about their areas? Their areas are congruent as well. So what I'm going to do is I'm going to take that triangle right there, okay? And I can move it around. I'm going to rotate it. Okay, so would you agree that area is the same as that area right there? When I do a rigid motion, distances are preserved, so areas are preserved. Cut that triangle off of my trapezoid. I'm going to rotate it and attach it right there. Okay? going to do the exact same thing over here. So would you guys agree that through the same process, those two triangles are going to be congruent? Okay. So I'm going to rotate that angle, or triangle, sorry, and I'm going to attach it right there. And when I do that, you see now that I've created this purple rectangle, right? Okay. Which that purple rectangle is just the repositioned areas of the trapezoid. When I cut those areas off and rotated and moved them, I didn't increase any area and I didn't decrease any area. They're the same, they're just repositioned, right? So what is the area formula for this purple rectangle? Base times height. Base times altitude, right? Now my altitude was that distance there, right? I'm still going to call that h. Okay, so and finding the area of this purple rectangle, it's still h. But what is the base? What is this distance right here from there to there, or up here from there to there? What is that distance for the rectangle?
Oh, it's in this thing.
Yeah, it's that's B1, right? So we agree that the base for the rectangle is bigger than B1, right? This is B2. So the distance, the base of the rectangle is smaller than B2. But isn't it exactly the same as that right there? So this B is actually 1/2 B1 plus B2. And I got to multiply by h. Okay? So I get 1/2 h B1 plus B2 to be the area of that rectangle, right? Well, the area of that rectangle is simply the area of that trapezoid that we started with, isn't it? Okay. So that procedure, that process provides us that the area of a trapezoid is 1/2 h B1 plus B2. Okay? And we create that by just repositioning some areas. Reposition some triangles that we have congruent to create that rectangle. And then using the area formula for a rectangle. And a lot of our formulas are developed that way. And everything up on the whiteboard to your left, those 6 formulas up there, all relate back to a rectangle, correct? And we've generated a lot of those so far, and we see that they all come back to base times height, or have a foundation in base times height. Does the trapezoid have a foundation in base times height? Yeah, okay, or base times altitude. So what I want you to understand, without the area formula for a rectangle, we don't have area formulas for everything else. Okay, that's the kind of unifying, tying together principle for all these formulas. You're going to use that a little bit in your homework. Okay. Obviously, once you find h, b1, and b2, you plug in the formula and evaluate through your algebra. Okay. Now, am I going to explicitly give you what b1 and b2 are? Probably not. Am I going to explicitly give you what h is? Probably not. Okay. So you're going to use SOHCAHTOA, special right triangles, that kind of stuff to generate those values.